Hello, this is Susan Poss, and I'm going to be talking with you today about section 2.1, which is simplifying algebraic expressions. We're going to be learning some vocabulary words, and we're going to be talking about combining like terms, and we'll eventually be looking at evaluating expressions. So I'm going to split this up into two videos so that it's not so long. The first one I'm going to call section 2.1.1, and then when you see me move on into the second video, it'll be 2.1.2. All right, so let's begin with our definitions. What is a constant? A constant is a number without a variable attached. A constant is a fixed value, so it is not changing, it's not going to vary. And examples of constants can be fractions, can be negative numbers, can be zero, can be a decimal, even can be a number like pi, or some of you will go on and learn about a number called e. Those are fixed values, therefore they're called constants. A variable is a letter, and that letter may be replaced with some number. That's why it's variable, because the value of it depends on what the replacement number is that goes in that spot. So here are some examples of some variables: x, y, z, w. This one is very important. What is the definition of a term? A term is a constant, so it can be just a single number, or it can be a variable. So those are both terms. Those are two different terms. And more likely, it will be a combination of variable or variables and constants that are bound together with multiplication or division. So those are examples of terms there, and it's going to be important for you to be able to recognize a term. So a variable term is, of course, a term that contains some letter, and the example there is 3x. A constant term is a term that does not contain a letter, an example there is -4. And another important definition is the word coefficient. A coefficient is a numerical multiplier of a variable. So let me show you some examples. Let's say that we just have the single letter x. That is a term. And something that you will need to understand is that there is a multiplier of 1 sitting out in front of that x. So that 1 would be referred to as the coefficient of x. And we might have something like -5xy, and of course the -5 would be called the coefficient. Sometimes I refer to it as the numerical coefficient. One other thing, let me show you something that's a fraction. Let's say that you have x over 13. And again, you have to be aware of the fact that there is a numerical coefficient of 1 in front of that x. So the numerical coefficient of this entire term would be this 1 over 13. So numerical coefficient or coefficient is a multiplier. Here's some quick examples. You can see we have on the left column, we have some terms identified, and the numerical coefficient for this first term is that numerical multiplier. The second example has a numerical multiplier of 5, so that is called the coefficient. Here's one that I talked about earlier, where you need to understand that there is a 1 in front of that x. So here we would define the numerical coefficient to be 1 over 7. And again, we have a variable y that does not have a number showing out in front, so that is understood to be a multiplier of 1. So that numerical coefficient is 1. And just as an aside, if we had a -y, the numerical coefficient would be -1. All right, so moving on, like terms versus unlike terms. So the qualifications for like terms is that they must contain exactly the same variable or variables, and those variables must contain exactly the same exponents. So let's see, like terms might be 3x and 1/2 x, same variables with exactly the same exponents, and we haven't talked about that yet, but these exponents here are understood to be ones when I don't write them down. So we might have negative 2ab and positive 1/3 ba. Those are still alike, even though the variables are in a different order. We can turn that order around using the commutative property of multiplication. So those are considered to be alike. And let's say that we have 0.5 y squared z and a negative 4 y squared z. So you can see that those contain exactly the same variables with the exact same exponents. So, unlike terms, they do not have the same variables and they do not have the same exponents. So let's say we had a 3x and then we had a 1/2 x to the second power. Those would not be alike because the exponents do not match. Let's say we had a negative 3a squared b and a positive 4b squared a. They have the same letters, but those letters do not have the same exponents. So those would not be considered like terms. And here, let's say we have a 0.7 yz, and over here we have a negative 5 xz, and those would not be considered alike because they don't contain exactly the same letters. So the reason it's important to know what terms are alike and what terms are not alike is that the ones that are alike can be combined or condensed into a single term. So we're starting off here with a couple of fairly simple ones. And I'm going to stop right there, so let me scroll just that far. So I'm looking here at these terms, 8x plus 7x. I'm noticing the variables are exactly the same, and the exponents are both understood to be 1, so that means I have like terms. So how do we combine like terms? Well, the way you combine like terms is you keep the same variable component and you add or subtract, depending on what the operation is, the numerical coefficients. So again, all of these vocabulary words are now very important. So when I take 8x and add it to 7x, noticing that they are alike, I combine the numerical coefficients and keep the common x. Same thing on this next example. I see the common like variable x, and what's going to be combined here are the numerical coefficients. And of course that's going to lead me to 3x. And on this last example for this first video, you'll see that I have 3 terms. 2 of them are variable terms, and the middle one is a constant term. So the 2 variable terms, do they have the same letter? Do those letters have exactly the same exponents? Yes. So I'm going to combine, oops, I don't want to change the order even though I could. I'm going to keep it the same. I want to combine the 4 and the 3. I want to keep the common x, and then this plus 2 out here is a constant term, and since it does not contain the letter x, it is not like the 7x. So these are unlike and they cannot be combined. All right, so I hope that helps us get started with some of the vocabulary of like and unlike and terms and coefficients. And I'm going to stop right there, and I'm going to continue on in the next segment.